Okay, this is going to be over how to do Lewis dot diagrams, or Lewis dot structures. So we're going to look at a couple here and kind of how to do it. I want to do both an ionic one, so that's going to be NaCl or a table salt. And then we're also going to do nitrogen, gas, and then carbon dioxide too, to kind of get a view of two covalent bonds. This is a diatomic bond, and then a ionic bond. So first you want to look at how many valence electrons there are on each one, and so we can do that by looking at what group they're in. So if they're in group 1, 1, 2, 3, 4, 5, 6, 7, 8. Just look at the last number at the top of the group. So Na has 1 valence electron, Cl has 7 valence electrons. Now there's the octet rule, octet, which just means they want 8. And then there's another rule, like the duet rule, that says they want 2, and that's for hydrogen. So Na has 1 electron, so start on any side, but to envision it, what you want to do is you have your element, you're going to split it into quadrants. So when it's full, and we'll see this on chlorine, there's 2 dots on each side. So Na has 1, Cl has another, or Cl has 1, 2, 3, 4, 5, 6, 7. So Cl wants 1 more, so that electron will transfer. We designate that showing an arrow. So it could be finally written as Na Cl 1, 2, 3, 4. Okay, it could be written such as that. Okay, so there we didn't really have to do anything too fancy, but now things are going to get harder. So N2. If we look at our periodic table, it's in group 5, so it has 10 electrons. So there's 5 electrons from each atom, so we're going to multiply it by 2 because there's 2 atoms. So that gives us a total of 10 electrons, okay? Now I'm going to write them side by side, N, N. And I'm going to put a bond between them. 1 bond represents 2 electrons, okay? And so that's going to make it 8. But now if I run around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't have 14 electrons. I need another bond. So another bond, 6 electrons. 1, 2, 3, 4, 5, 6. Well, if I can only fit 6, 7, 8, 9, 10, I'm going to need another bond because I can't fulfill the octet rule for both nitrogens. So we put another bond here. So it's 1, 2, 3, 4, 5, 6. So let me subtract 2 again, so that'd be 4 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gets rid of all 4 of our electrons. And we have 1, 2, 3, 4, 5, 6, 7, 8 for this nitrogen, and 1, 2, 3, 4, 5, 6, 7, 8 for this one, fulfilling the octet rule. So nitrogen gas has a triple bond. Oops, not an O, an N, with 2 valence electrons on the outside. And CO2, this one's really tricky. So O is in group 6, so it brings 6. We have to multiply that by 2 because we have 2 atoms of it. And then carbon brings 4 because it's in group 14. So that's a total of 16 electrons. So I'm going to write my carbon and then my 2 oxygens by each other. And I'm going to try 1 bond for each. So that's going to give me 12 electrons. 1, 2. So if I wanted to get 4 on carbon, or 8 on carbon, 1, 2, 3, 4, 5, 6, 7, 8. To require 4 more electrons, so that put me at 8. Well, I need 6 for these other oxygens, so that's not going to work. So I'm going to put another bond here. And that's minus 4 more electrons. Now I have 8 electrons to use. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So carbon is happy right now, so we only need to fulfill oxygen. and each oxygen already has 4, so each oxygen only needs 4 more electrons. So 1, 2, 3, 4. It doesn't really matter where you put them. 1, 2, 3, 4. So now let's look. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And carbon has 1, 2, 3, 4, 5, 6, 7, 8. So each one has 8 electrons on the outside, fulfilling the octet rule. So for carbon, it's double bonded to oxygen. I'll write them on the opposite ways. So that would be the Lewis dot structure for carbon dioxide. I hope that was helpful.